Have you ever wondered what the devil these logarithms are? Let's do a brief overview. Stay tuned. A log is an exponent. Log is a short word for logarithm because mathematicians are lazy by nature, and we don't want to write this whole word out every time, so we write the word log. But it's an exponent. More specifically, it is the inverse operation of an exponent. But more on that later, probably next week's lesson. So let's continue. So since it's the inverse operation of an exponent, think of an exponent. So we had a base number, I'll use b for base, raised to some exponent, x we'll call it, equals a number, we'll call it the number n. So if I wanted to undo that, I would have to use this equation. So it would be a logarithm, or log, base b, we put a little subscript here for whatever base it is, of a number equals our exponent. So we have a base, that's this number here, same as this number here. We have another number here. This is called the argument, and that's the number over here. But in the logarithm, it's called an argument. And then finally, we get the exponent. This is the exponent, the same as up here. So these two equations, if they were real numbers, they would be equivalent equations. They undo each other. So we use logarithms to solve exponential equations. Now, keep in mind, logarithms come in all flavors. So we could have a log base 2, or a log base 4, or a log base 7. We math teachers use this one a lot because photomath can't do them. So if you see log base 7 on anything, you won't be able to use photomath. So in any event, the most common log that we use is ironically called, we'll scooch over here, it's called the common log. Common log. So common log is just a base 10 log. So let's suppose I had base 10, and my argument number is 100, say. And we know that this answer is going to be 2, because 10 squared equals 100. Pick another one here. Log base 10 of 1,000. Well, that's going to be equal to 3, because we know that base 10 cubed is equal to 1,000. So suppose we wanted to go like in between here, in here. So I'm going right here. I want to know, what is the log base 10, or the common log of 200? I don't know what that is. I know it's not a whole number, because 200 to what number? 10 to what number is equal to 200? I don't know, but I know it's between 2 and 3. So if I typed log 200 into a calculator, it's going to give me a number that is between 1 and, or not 1, but 2 and 3. So log 200. So that's kind of how those work. They're just the exponents, but since 200 is in between 100 and 1,000, the exponent that 10 gets raised to is going to be between 2 and 3. So hopefully that helps you think about these a little bit better. Stop it and rewind it if you need to listen to it again. I'll be here for the next one. So I threw a few practice problems up here. It's just practicing rewriting a logarithmic equation in exponential form. So on the left-hand column here, I have the logarithmic form. In the right-hand column, I have the exponential form. So right here, I'm looking at base 8 raised to the first power equals 8. So if I were to rewrite that, it would just be 8 to the 1 equals 8. Now, ordinarily, like I said before, we wouldn't write 8 to the 1. We would not include this. But we're just doing it to show an example here. So, log base 8 of 64 is 2. That means 8 squared is 64. So if I wrote that as an exponential equation, it would be this. Now, keep in mind, this equation and this equation, they're they're equivalent equations, right? If they had variables in them, they would have the same solution. So those are equivalent. So let's go to the next one. So notice here, we started with 8 to the 2/3 equals 4. So what's our base? Well, that base would be log base 8. Try to keep them all the same here. Log base 8 of, what's my argument? 4 equals 2/3. So that means 8 to the 2/3 equals 4. So think about that. 8 to the 2/3 is the same thing as the cube root of 8 squared. So we know that is the cube root of 64, which is 4. All right, another quick practice. 8 cubed is 512. So my base is 8. So when I write my logarithm, I'm going to write log base 8 of, here's my argument number, 512, gives an exponent of 3. Two more to look at here. So again, sticking with the base 8, my exponent is -8, and my argument is 1/8. So that would be 8 to the -1 is equal to 1/8. And last but not least, this would be log base 8 again, because that's my base number, and 1/64th would be our object number, and then that gives us an exponent of -2. So there you go. A couple of quick examples. Hopefully this is helping everybody understand it better. Let's consider some of the properties of logarithms. So log base b of 1 equals 0. So whatever the base is, if the argument is 1, it's always going to be a 0, because think about this. Base b to the 0 equals 1. So that's my exponent. Any number raised to the 0 is equal to 1. So when you have a 1 here, whatever the base is, this will always be 0. Okay? So these sometimes you have to study with or work with a little bit before they start to kind of come into play. So when my base number is equal to my argument, well, that's going to give us a 1. Think about that. Base b to the 1 equals b. Okay? Looking at the next one, this is another property of logs. Base b of b to the x equals x. So take your base number and take your exponent. Hey, look at that equals this number here. So that's like saying b to the x equals b to the x. Whenever these two numbers match, I'll look at one on the next screen, but if I have log base 3 of 3 squared, that's going to equal 2 because the two 3's match. So that will always be the exponent. And this is equivalent to this. So here we're looking at a base b, and the exponent is log base b of x. It's always going to equal x. So think of it this way. Suppose I had, let me do a different number. Let's do 5. So if I had 5 to the log base 5 of, I don't know, some number 3, that is always going to be equal to 3. Here's a couple of quick examples. So remember, whenever these two numbers match, undo that. Whenever these two numbers match, we're going to have a 1, because 2 to the 1 equals the argument number right here of 2. Now, remember the other property? Whenever this is a 1, doesn't matter what this base is. Anything raised to the 0 is 1. So if you have an argument that's 1, it had to have come from 0. Erase that. Had to have come from 5 to the 0, because anything to the 0 is 1, except for 0. All right, last but not least, we have two more matchers here again. So it's kind of like this one up here, but here my exponent was 1. Here my exponent is 5. So that just becomes a 5. So the more you do these, the more they'll kind of jump out at you after a while. But this is just very beginner stuff. So let's go to the next slide. So the natural log is base e. And you might be wondering, well, what the devil is base e? Well, e is a irrational number that comes from the financial world is where we use it a lot, but it's used in a lot of other places. The e is for exponential. Some people think it's for Euler. Leonard Euler is who kind of made it famous. But anyway, base e just means it's 2.718 to some power x. It equals what number? So my argument is still some number here, and it's equal to an exponent here. But, all right, mathematicians, I guess because they're lazy by nature, have rewritten log base e as ln for natural log. It's probably Latin for something. That's why it's written that way. So the natural log of a number will yield an exponent. And all those other properties still apply as well. So if I had the ln of e, that would be equal to 1, because that'd be like saying the log base e of e is 1, because e to the 1 is e. So these rules, these properties from the previous section still would apply. So, but we just are, like I said, we use ln in place of the log. And a log can actually be any base. So just like with some of the examples I was using a base 8, a log could be log base 2. So log base 2 of 8 is what number? Well, that would be 3, because 2, the base number, raised to the 3 equals 8. And that's our argument right here, is 8. So hopefully you got some value out of that. So stay tuned. I think maybe next Tuesday we'll do some more looking at the next level of logarithms. What actually are they, and where do they come from, and why do we need them? Okay, stay tuned. So there you go. There are your logarithms in a nutshell. If you got value from this, go ahead and subscribe. Then you won't miss any of the topics that we have coming up. Until next time, this is Mark Nolde out.